Hi, Joe Cerrone. Welcome to CAD 107, Introduction to 3D Printing, in our weekly Zoom classroom meeting. We'll run these meetings on Wednesday mornings from 9:30 a.m. to 10:30 with the following Zoom link. This week, we'll be working on the Coasters Lab, lab number 2. In this exercise, what we're going to do is we're going to download the template for these different coaster files, and we're going to model those using AutoCAD, and we're going to create them to a thickness of 5 millimeters, and then we're going to create one of our own designs. Here's the information from last week's meeting, and here's the assignment number 1, the door, the video announcement door sign. If we take a look at the calendar of events, Chapter 1 review questions are due next week, Wednesday at 11:59. And then Module 2, which we're assigning today, will be due on February 15th. If we go to the contents section, here's the information for the lab. You're to open the student file, model the coasters using AutoCAD, use press, pull, or extrude at a thickness of 5 millimeters, fill out the title block, save the drawing, replacing the X's with your initials, export the STL file, and open it into the slicer. And we'll turn in the CAD drawing file and the STL file. You don't necessarily have to turn in the G-code file that's produced within the slicer. So let's get started. Okay, we have these different designs that are available, and as we look at additive manufacturing and working with 3D printing, we want to be able to understand how we'll work with these different CAD models. And so I'm going to go to the first one, download that, and open it. And so here's the drawing file, and this is what's called layout mode or paper space. And if I turn the wheel on the mouse, I can increase the magnification. If I turn it the other way, I can decrease it. And so essentially, we're going to model these coasters, and we have the 2D version on the title block, and then to model it, we go into the modeling tab right here. And what we're going to do is we're going to go and change the view to a southeast isometric view. And then I'm going to zoom in on this by turning the wheel on the mouse. I'm going to switch over to a modeling tab. I'm going to go with 3D modeling. And we'll see that the ribbon will update for that information. I like to use the menu bar, so I'm going to show the menu bar. And then as we work with additive manufacturing, we want to make sure that the geometry is connected. And so what we will do is we will extrude the model using press pull. And then if I were to extrude it from this point right here, I can select it and I will make that 5 millimeters. And this is a valid geometry for 3D printing. Everything is connected. We're not going to leave any pieces that would be stuck to the build plate. And I'll give you an example of what I mean by that. And so everything is connected, so once this part is printed, it will print it layer by layer, and it'll be one piece. Whereas if I were to undo this and we were to press pull some of the individual components, we would be able to 3D print these objects, but it would be in individual pieces. And so from a standpoint of manufacturing for additive manufacturing, this would not be a geometry that would work as a coaster. It would work as a bunch of pieces from a jigsaw puzzle, but not for what we're looking to create. So I'm going to undo that. And then we'll do this again. We'll say press pull. We'll hover in this area right here where everything is connected, and it's designed like that. So we'll say 5 millimeters, and then we'll save the file. And so we'll hit escape. And what we'll do is we'll go and save it 2 different ways. Before I save it, I will update the title block But while I'm here in model space, I'm going to export it as an STL file, which is what we use to run the 3D printing slicing software. So we'll go to the big red A, we'll choose export, other file formats, and I'm just going to put this in my downloads. I'm going to change this to an STL file, standard triangle language, and then I'm going to update the name of the file to my initials, and I can get rid of this other business here. It will add the STL suffix to that, and I'll hit save, and then you have to actually click on the geometry and hit enter to create that file, and it'll tell you one file was found and then it created that, and we can look into our downloads and see that that file exists. So that's part one, model the part and export the STL file, and then let's update and make the engineering drawings look good. And so here's our drawing. You can see that the viewport has updated with the 3D model in it. And really all we need to do here is fill out the name. And so you can put your name here. And then as far as the scale of this, we're just going to leave it as fit for right now. If I double click in here, I can check on it, and it's scaled at 5%. So we'll just leave that. We'll save this file. We'll say File, Save As, and this is going to be a drawing file that's going to be saved. And so again, we'll just change the initials. And so this will be my lab A, and I'm going to select the downloads for that as well, and I'll hit save. And then what we will do is we'll go into the D2L system and we'll submit those drawings. And so here's our D2L system. We'll go up to the assignments folder. Here's our module 2. Here's our grading criteria. And then we can add the file, and we'll add more of these as we go along. I just wanted to do this for the first one. And here's my downloads, and here's the CAD drawing file, and here's the STL file. So I'm just going to hold Control and click on both of those. I'll say open, and I'll add those, and then you can add a note. And we'll submit that. And so that's how we're going to work with lab number 2 as far as files to be submitted. We will go through your CAD files and your STL files, and we will print those for you. Remember, you're welcome to come in and make an appointment to 3D print your own files on Wednesdays during the class, but we have it set up so that you can have your files printed and then pick them up from room P130. And what we will be doing is putting a bin with your student ID number on it. And it'll just be the last 4 digits of the number, and you can come and pick up your files when you're on the Skokie campus. All right, continuing on. Okay, so we have gone through and we have created the model for this drawing, and we've created the STL. So the next step is to run the Dremel Digi Slicer. And so here's my Dremel Digi Slicer. If you look at the main splash page, I've given you the information to download the software. It's free. And what we're going to do is we're going to open our downloaded files. And so here's my 2A. I'm going to open that. And it came in just perfectly. It didn't select it on an angle or move it. It fit on the build plate. As we take a look at the Dremel Slicer, I'm going to collapse these different settings and we'll check them. And we'll introduce these settings a little bit at a time. The first thing that that we wanted to do is to make sure that we have it set up for the Dremel 3D 45. And then the next thing is the material. And we're going to be using polylactic acid, or PLA. We have a number of other materials with different material qualities, but we like to use the PLA. It's biodegradable, it's relatively inexpensive, and it works well for this application. So now that I have those basic settings set up, I can also take a look at the quality level. And we tend to print these on low quality. It's not a bad surface finish as we look at setting it up at 0.3 millimeters. We can always go and increase those quality levels for higher quality prints depending on the application. But for our application, this will be fine. So I'm going to leave it at 0.3 mm. And then as far as everything else goes, I'm just going to take a look at the support. We don't need to generate support for this because it's a flat part. There's nothing that's like up and has to be supported to allow for 3D printing. And so we're going to leave the generate support unchecked. And then for build plate adhesion, I'm going to leave it set up at none. And I may change this as we print, but as we take a look at it and we take a look at how we've created this, what we want to do is we want to prepare it. And so I'm going to click prepare, and I'll show you what build plate adhesion does. So once it's prepared, it'll tell you how long it's going to take. It's going to take 1 hour and 24 minutes. And then we go over to the eyeball here, and we take a look at the layers. And then this part will print in 17 layers. And we can go through these different layers and take a look at what we're getting here. And so what we're getting is the first layer right here. Okay, it'll create this perimeter shape, and then all these little zigzags, that's your infill. And so as we go and we create this model, you'll see that it creates it layer by layer. Layer 2, layer 3. And I'm not sure what happened. I must have moved it or something because it says it's ready to slice. So sometimes if we do that, so I'm just going to click off the part, prepare it again. And then here we are again, same place. And so I can go through and prepare that for printing. And we can see that for basic introductory work in 3D printing, this is the technique we're going to start with. Do I need support? No. Build plate adhesion, maybe. Depending on how we see how these print, what has a tendency to happen is the corners sometimes will start to lift off on heavy prints or large prints. And so occasionally we'll have to use build plate adhesion to make sure that it doesn't warp. And if we create a brim and then I prepare it again because we have to reslice it, this will hold it to the build plate. And we can experiment with the brim width if I want it to be that big, or if I want it to be 4 millimeters, re-prepare it. Now it has a little bit less, but it holds it to the build plate, which keeps it from warping. For this exercise, I like to run them without it for the first time. If it works well with none, great. If I wind up with a print that's bad, then I'll enable it because it'll add a little bit more time and some post-processing. So when we have a build plate adhesion on it, we have some cleanup work. We'll have to do some filing, or we'll have to take some clippers and clip off the build plate adhesion material. All right, and so once we have that component of it set, we can then come over here. Typically, I don't know why it puts on D3 on everything, but I usually back that out. It'll be my initials -2A, and then I will save the file to a USB. And so I'm going to grab a USB here and print to that. So it recognized that I put a USB in there, and that's how we're printing most of our projects over at the Skokie lab. We just use USBs. They are networkable, I can set it up for Wi-Fi and for cameras, but this is a very straightforward system that works quite well. So I'm going to save to the removable drive, and then I can eject that file if I need to and bring it over to a 3D printer and then put it into the USB drive and run the printout. Alrighty, so that is the technique. If we wanted to take a look at that file, we could take a look at it, but I think at this time we'll stay out of looking at the G codes, and we'll talk about that at another point. So just to recap, we create the model in CAD, and so if I go into the D2L system, I can go to the Content tab, and I can choose the next file, and so I can say Lab B, download it, open it. It brought me in model space in this one. Here's the tab for paper space and model space. And model space is where we do the work. Layout mode or paper space is where we display the drawing on the title block. And what I'm going to do is I'm going to go and change the view to southeast isometric. And then again, the same kind of thing as far as to being able to create the model. When I use press, pull, or extrude, I don't want a bunch of 5mm cubes. This would not be something that I would want to 3D print as a coaster. What I want is the outside perimeter shape. So I'm going to undo that. And then I'm going to use press pull. And where I select the press pull geometry is important because I want it all to stay together. And I'm going to make that 5mm in height. And that's basically it. These aren't supposed to be real difficult. We want to kind of walk you through the basic modeling with AutoCAD. I'm going to export it, going to the big red A, export, other file formats, STL, replace your initials, and save it. And then go and select the file, select the geometry and hit enter, and then it will actually export that as the STL. You actually have to select it. I'll go into the title block in layout mode, and then I'll put my name on it. And I'll save this file as a drawing file. And so the file extension will be DWG, and that's so that if we need to make any changes to the model, we can make changes in CAD. And then we can go into our slicing software, and with the way that it's set up, we could just add it. We have enough room on the build plate, so I could go and add B and open that. The settings will stay the same, and I can prepare it, and then I can take a look at that in the slicer. I can determine how long that will take to run. It'll take 2 hours and 53 minutes, and then I can save that to the USB drive and generate the G codes. All right, so that's the technique for creating the coasters from the existing geometry. Now, if we take a look at the last file right here, create one of or more of your own design, then we want to take a look at how we would do that. And we want to be able to design for additive manufacturing. And so we don't want any pieces like we talked about kind of hanging out in space that are unsupported. And so what we'll do is we'll download the E file, open it, and so this is the blank template. We'll go into model space, and then we'll create a design of our own. And so I can come in here and I can go and I can create a rectangle. And depending on how I want to create the rectangle, if I want it to be perfectly even, the best way to do this would be to offset these different lines. And so if I were to offset, and let's just say 5 millimeters, we can select the line and toward the inside, then we would be able to press pull this into basically a rectangular frame. And then if I say, well, I'd like to make, this geometry, and I'd like to have it, just kind of an interesting design, I'm going to switch my workspace over to drafting and annotation, which is 2-dimensional. I'll turn on my menu bar, and then I'll go through and create some geometry. And so I'm just going to create something with a circle in the center of it. And so just to make sure I get it in the middle, I'm going to turn on my object snap and make a construction line across the corners. And then I'll draw a circle at the midpoint. And I'm just going to create a circle like that. And I'll delete my construction line. Actually, I'll leave it in there. And what I'll do is I'll offset it. We'll go with 2.5 millimeters to each side. And we'll create another line from corner to corner. And we'll offset that 2.5 millimeters to each side as well. I don't need the middle lines, so I'm going to delete them. And then I'm going to trim. And so I'll say trim, and then I'll be able to select the areas. And we want to make sure that this is a valid boundary shape, which means that we don't want any crisscrosses. We want to be able to drive through the entire part like it's a road, or like one of those puzzles where you have to go through and go from one end to the other. And so creating a model for 3D printing requires a little bit of thought as far as to how the 3D printers work. We don't want any unsupported pieces hanging in the middle of space, essentially. Like that. If I had something like that, that would not be a good thing. So I'll take that out and I'll hit delete. All right, so that is going to be my 3D printed coaster. I'm going to go and model it now. I'll go to an isometric view. And then I'll select press pull. Now, what I could do is I could copy this so that it shows up in the drawing from this endpoint to this endpoint. And then when we look at the title block, you'll see that this part is updated. And then I'll model this with press pull. I'm just going to type it in. Hover, acquire the geometry, and then we'll bring that up 5 millimeters. And that's it. You can make this as fancy as you like, or you can make it as simple. But we want to be able to understand what's printable. I'll export it. Change it to my initials. Save the file. Select the geometry, hit enter. And then I'll go to the layout and I'll update the title block. My name on it. And then I'll save this file in case I want to make some changes to it at a later point. I'll need the CAD file. So I'll save this with my initials. As a DWG file. I can go to my slicer, and if I want to, I can delete these models So I can say clear the build plate, open, here's my new file. I can then slice it. It'll remain and keep the old settings. And that one's good to go. That's my basic part for my coaster design, and it's really quite simple. You can do quite a bit more with it if you want to take the time to embellish the design, and I'm happy to work with you on that. As an industrial designer myself, having worked in the field, I like to start with something simple, but there's no reason that you can't go through and make something that's a little bit more customized for yourself. And then I'll go through, I'll just take a look at the layers in the slicer, make sure everything looks valid, and then I can save it to the removable drive to generate the G-codes. Alrighty, so that's the basic technique for lab number 2. Remember to model these 4 parts and then create one of your own designs and then submit those to the assignments folder. If you have any questions, you can always email and attach the file geometry if you need to have any questions specific to that. Or if you want to come in the lab and make an appointment, let us know when you're coming. With that, I'm going to end this recording and I'll post it in the announcements.